So welcome back, friends. And in this chapter today, we will learn about some advanced Java topics. Like first of all, we will cover equals and hash code, which is the basis for managing collections in Java. And then we will learn about collections in Java. So we'll learn about the list interface, we'll learn about the set interface, we'll learn about the map interface, we'll learn about maps as well, we'll learn about queues, we'll learn about iterators, we'll learn about streams, we learn about generics in Java, what is their use and what is their purpose. And we will also learn about lambda expression and functional interfaces. So it's going to be a very exciting topic today. So let's get started. So first, let's cover equals and hash code. Okay. So suppose I have a student class. So I define a class which is student. I have a string name, string. Let's not take string. Let's take int age, and we have a int class. In which class? Standard. We have a int, and we have all the getters and setters for the student class. We also have the constructor. So we have the student class here. Now, if you don't know what is a constructor, we have discussed this topic in our previous videos. Please check what is constructor. Okay. Now we suppose we create many students of this using this student class. So we create student s1 is equal to new, and we have a all argument constructor as well. So we pass Ravi, age 8, standard third. Again, we do S2 is equal to new student, and we pass Sunil, age 7, standard 2. This way we create many objects. Okay. And suppose there is a strange situation in one of the class. The standard 3 has two students with the name Ravi, whose age is also 8. So these are two different students. Okay. So we have student S3. His age is also 8, and he also studies in the third standard. But these two are different students. Okay. Child of different parents, different homes, but they study in the same school in the same class. So how will so this means that we should have something in our student class which would be able to uniquely identify a student. Okay. So we modify our student class and we add one more very important property, which is string roll number. Now we need to, when creating a student object, we also need to define a roll number for each student. So what we need to do is we can say A1 is the first roll number, A2, and again A2. Now all the students in the same class, in a particular class, will not have the same roll number. So if I want to differentiate whether these S1 and S3, whether they are the same child or different child, how can I differentiate? For that, the general convention is in the student class only you should override the equals method. Okay. So what we need to do here is, let me create some space here. In this student class, in the object class, which is the the parent class of all classes in Java, there is already a equals method present. But when you create a new class, and all the classes that you create extend this object class, okay, because it is a parent class of all the classes in Java. Now you may use this equal method, but it will not be helpful. The equals method is used to define or check whether two given objects are meaningfully equal or not. So what do we mean by meaningfully equal? By meaningfully equal, we mean whether student S1 and S3 are the same child or not. Here we know that S1 and S3 are two different child of two different parents. They live separately, but they study in the same class. What differentiates S1 and S3? Their roll number is different. Here we also need to mention their standard in which they are studying. So both are studying in this third standard, both of them, but both of them have a separate roll number. So how do you tell this in the code? How do you define it in the code so that the code is able to easily identify whether S1 and S2 are the same child or not? S1 and S3 are the same child or not? So you can do it in many places. You can, wherever you are using the student class, you can write if else block and you can place checks for this comparison for this. But the standard way of doing is it to place this logic in your equals method. Why? Because your equals method is used to compare or check whether these two students S1 and S3 are meaningfully equal or not. Okay. So the format of equals is public boolean equals, and it takes a object reference object o1. So now this external object o1 that you pass, you compare it with your this instance and you check whatever you want to check to define whether both of them are meaningfully equal or not. So for two students to be meaningfully equal, because there can be multiple childs with the name Ravi, or there can be multiple childs with the same name. So we are deciding, we as developers are deciding that these are the two important properties that cannot be same for two different childs. One is they should be studying in the same class and their roll number should not be same. Okay. So no two childs in the same class should have the same roll number. Different childs in different class can have the same roll number, because roll number will also always start with A1, A2, A3, A4 for each of the standards. But it will not be same for two students in the same standard. Okay. So what we will check is, maybe we can take a Boolean property or we can directly check. What we will check is this dot name, and we will use the equals method again, one dot name, and we will check this dot standard equal to one dot standard, and we also need to check whether their roll number is same or not. If their roll number is same, the child is same. If the roll number is not same, the child is different. So we will add a and condition to this, and then we will check this roll number, and we will use the equals, because roll number is type of string. Okay. Now string class also has a equals method. Okay. So we'll use this. Now equals method in string class is used to compare whether two strings are equal or not. So we can do this comparison, A1 is equal to A2 or not, or it is different or not. It will check meaningfully equal. Okay. Equality. So we'll call this method and we will do O1 dot roll number, and we will return this complete comparison we will return from our equals method. Okay. So this will help us defining what all properties need to be checked to identify whether given two objects are meaningfully equal or not. You can see that we are not using age here. We are not using age, we are not using name. The reason is that name can be same for two different childs as well. Okay. Age can also be same, but roll number and standard combination must be unique for each and every child. So we as developer have to identify, realize that which combination of which properties is unique for a given student, and then use these properties in comparison in the equals method. So this is how the equals method is defined. Now let's move to the hashCode method. Going further in this video, we will learn about collections. So basically collections is managing a group of similar kind of objects. It is a way, but collections are used to manage similar kind of different objects. So you have 100 students in a class, 1,000 students in a school. So you will use different collection classes available to manage them. Now there are different type of collections. There are lists, there are sets, there are maps, there are queues. All of the collections have different purpose. We'll learn going forward um, in this lecture. As of now, what we need to realize is there is a hashcode method. This hashcode method is used for arranging different objects of same type within a collection. Okay. So the syntax of hashcode method is public hashcode, and it is also there in object class. But object class doesn't have any properties of our use. When we create student class, although we get the inherited hashcode method from the object class, but that is not of our use because our student class has some properties which define the significance of this student class. So we should use these properties, and using this property we can say how our how different student objects should be arranged in a collection. So now it is up to us to decide. For example, we chose standard and roll number to define how uniquely your student object can be identified. Now what you can do here is you can use any of the properties or a combination of all of the properties to define hash code, but the output should be an integer. So the ideal thing that I decide here is the simplest thing that I can do is we can say return this dot roll number hash code. Remember, roll number, we can see here that roll number is a string, so it also has a hash code method available in it, which will return hash code for this string. But we need to implement a hash code for this object. It has many properties. I can do simply this. So this will return me an integer. And because why I'm choosing a roll number, because roll number is unique for each student, but it is not unique for students of different class. So maybe we should modify this. What we can do is we can multiply it with this dot standard and then return this. If you want to make it more foolproof, if you want to add more uniqueness to this, it is up to you. You can also modify it forward and multiply this dot name, and you can use the fourth property as well, which is age. So you can multiply by this dot age. So basically the intent of this hashcode method is it should return an integer which will be used in the arrangement of the objects of the same type, of the different objects of the student class. Okay, so it should be relatively how these objects will be arranged. This response from the hash code is used for that. Okay, so now important thing to realize is two different student childs or two different objects of the student class might still have a same hash code, because it's maths. We are multiplying different integers, so using combination of different integers we can still get a same number. So that is why there is a defined rule in Java, which is two objects are equal. They should have the same hash code. Two objects have same hash code doesn't surely mean that they are equal. When we say two objects are equal, we mean that their O1 dot equals O2, it returns. So if O1 and dot O2, O1 dot equals O2 returns true, which means if two objects are equal, they should have the same hash code. This is how we should implement this method. This is a general rule for implementing the hash code method. Okay, so this is how we should implement the hash code method, that if two objects are meaningfully equal, they should have the same hash code. If two objects have the same hash code, doesn't mean that they will surely be equal. They can be equal, they cannot be equal as well. So this is an unset contract. When I say it is an unset contract, it means that the compiler will not force you to implement this contract. You should still implement this contract for a better arrangement of your objects in a collection, and for better management of your object and better management of your objects. You should implement this. It is not compulsory, but it is still expected for better quality. So in this video, we learned about the equal and hashcode method in Java. It is very elementary and you should learn it with lot of detail. And in coming videos, we will see how we will use the equals and hashcode method. Okay. So this is the student class that we spoke about. Okay. As we can see, we have 4 properties: name, age, standard, and roll number. This is the all argument constructor. Then we have the getters and setters, as I already explained to you. So this is how we have implemented equals method here. It always takes an object as input. So first we need to cast that object into type student. Okay, we have casted it into student, and then what we have checked, as I showed you earlier, is we have compared using standard. So this is equivalent to saying this dot standard. If you don't write this, then also it picks up the this property only. Okay, so we are comparing student dot standard with standard, and again we are comparing student dot roll number with roll number. So this one is this dot roll number. Okay, it is written in this way here: object dot equals. What you could do is you can call this method as a utility method, which also calls the equals. Here you can see it is calling a1 dot equals a dot equals b, what we had written. It is just placing some additional null checks here, and it is checking whether both objects are similar or not. So you can do this. Otherwise, you could have simply done this roll number equals. This is what we wrote in the code example. So both are things. So the concept here is same in both of them. It is a standard way of doing it, using this object or equals method. You can say that some additional checks are there, but eventually it is doing what same thing. It is calling the equals method, which we showed in our written code example. So this is how we have implemented equals method here. This override annotation is also optional. You may write it or not write it, but it is a good practice to write it. It will check whether the signature that you are using for the equals method is correct, because this is an inherited method from a parent class. Okay. Similarly, we have hashcode method. Here also we are using object.hash. You can, do this roll number dot get hash hashcode as well. Okay, you can do this standard, how we did it, multiplied by. You can do this. Okay, if you want, you can use other properties as well, which is name and age as well. Okay, but this is again a utility method which is already available in the objects class. It is a static method. You can use it, and it eventually, if you say its implementation, it will also call the hashcode method of each of the elements. Okay, which we were doing directly. Okay, so you can, if you want, you can pass more properties here. You can pass name, and you can also pass age. It is up to you how you want to override your hashcode method. But you should always remember that a rule, that if two objects are equal, they should have the same hashcode. And if two objects have the same hashcode, they may or may not be equal. This hashcode method should follow this contract. Okay. In fact, both equals and hashcode should together follow this code. I'll see you in the next section. All the best.